Hello friends, this video on vector algebra part 2 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 into vectors and scalars. 10 kg. So if you see 10 kg, it has a magnitude, that is 10 kg, but there is no direction, right? We are not saying that this 10 kg is in east direction, west direction. So direction is not involved. So I told vector is nothing but magnitude per direction. So this guy has only magnitude, no direction. So this guy is scalar. When you say 21 meter northwest, that means I'm talking about some meter in northwest direction. Correct? 21 meter. So this guy has magnitude 21 meter. Direction northwest, yes. So it is vector. Let's take an example. 30 degree. 30 degree has direction but no magnitude, right? So it is a scalar. $70 again, it has a magnitude but no direction. So we don't talk about 70 watt in east direction or west direction. So it's a scalar quantity. 10 to 17 coulomb, again the charge. So this is all about quantity. 17 coulomb charge, 18 coulomb charge. It has no direction. So it will be a scalar. Correct? 25 meter per second square. What is this? This is acceleration. So acceleration, when we talk about acceleration is nothing but if you don't understand physics, then you may not understand this, but just give it a shot. Acceleration is nothing but rate of change of velocity, and velocity is a vector because velocity has magnitude and direction. So acceleration also has magnitude and direction. We talk about acceleration in some direction. It is not given here, it is implicit actually. There has to be some direction for acceleration. We just don't talk about acceleration just like that. When we talk about acceleration, we talk about direction also. So this is a vector. Though in this question it is not given 25 meter per second square in east direction or west direction, but when we talk about acceleration, we always talk about direction. So here direction is implicit. So it is vector. Please don't be confused. In this question, direction is not mentioned, but when we talk about acceleration, we always talk about some direction. Time period, the scalar, it has a magnitude. There is no direction. We never talk about 30 years or 40 years in east direction or west direction. We just talk about 30 years. If someone asks me, how old are you? I say 40 years. I never say 40 years in west direction. Correct? Distance. Distance is again a scalar. Why? Because when you say distance, you talk about only length. You say 50 meter, 60 meter. You never talk about 50 meter in east, 50 meter in west, right? So it is a scalar. Force. Force is a vector. Why? Because when you talk about force, you talk about direction. You say X, or let's suppose 10 Newton force in east direction. So here also it's implicit actually. Whenever you talk about force, example, when you say this is a body and I'm applying force, you always give a direction. If force is in this direction or this direction, this direction, force has a direction. So it is a vector. It has magnitude, it has direction. Velocity. Velocity, as I told, has direction and magnitude. When it say velocity, I'm talking about, let's suppose I'm going with 5 meter per second in northwest direction. This is the velocity. So when I'm talking about velocity, I'm talking about magnitude and direction. Speed. Speed is not a vector. Please note, speed is something velocity minus vector. Why? When I'm saying speed, I'm telling only 5 meter per second. I'm not telling direction. But when I'm talking about velocity, I'm talking about speed and direction both. This is a trick in physics actually. If you are a physics student, you'll understand it better. When you talk about speed, you talk about only magnitude, 50 meter per second, 10 meter per second, like that. But when you talk about velocity, you talk about speed plus direction. Work done is again a scalar. So when you say work done, you don't talk about direction, you just talk about the work done, that's all. Torque. Torque is something which is vector. So torque is nothing but a rotational thing. So you have this object, let's suppose it is hanged somewhere. You apply this force, it rotates, right? It rotates, this guy will rotate. So the rotational capacity is called torque actually, and this has both speed and direction. Why? Because it talks about at what speed it is moving and which direction is moving. It's clockwise, anti-clockwise, this kind of stuff. So torque is something which has both speed and direction. So torque is a vector. Please note, this torque is a vector. This is something which we'll use in future slides also, where we'll learn more concept based on this factor. Torque is a vector, correct? Torque is nothing but a rotational thing. So when you apply some force here on this rod, it rotates. So that is a vector. So let's repeat. 10 kg scalar, only magnitude. 21 meter in northeast, magnitude and direction, vector. 30 degree, only scalar. Only it's talk about degree, it doesn't talk about direction. 70 watt, scalar, no direction. Coulomb, scalar, no direction. 25 meter per second square, this is a unit for acceleration. When you talk about acceleration, you talk about direction also. So it's a vector. Time period, scalar, no direction. Distance, scalar, no direction. Force, vector, because when you apply force, you talk about direction at which you apply force. Vector, velocity is a vector and speed is not a vector. Why? Because velocity is your speed in a particular direction, and speed you don't talk about direction. Work done is again a scalar because you don't talk about direction, work done, and torque is a vector. Please note here, in case of torque and work done also, the unit is same actually. The formula for both is F into D, force into distance. We'll explain more on these in few slides. The first thing which I want to tell you guys is, when you talk about vector, we'll talk about some coordinate system. We'll always use right-handed coordinate system. So when you say move from x to y, it has to go to z. For example, this guy is a right-hand coordinate system. Why? It applies your right-hand thumb rule. You take your right hand. Please take out your right hand. Fold your palm in this fashion, right? So you move from x to y like this. You move from x to y. Your thumb should point to z direction. Please note, you fold all these four fingers from x to y in this fashion, correct? In this fashion, your thumb should give a direction of z. In this case, if you try, you mold from x to y, correct? You mold from x to y, your thumb comes out in this direction, but your z is here. So this guy is not a right hand coordinate, but this guy is a right hand coordinate. That is why I took this example also. Please always make sure that for our study, we talk about right hand rectangular coordinate system only. Correct? Whenever you get any x, y, z axis, you rotate your four fingers from x to y, and then please make sure that your z is towards your thumb, right? So if you have this kind of thing where if you rotate from x to y and your z is towards thumb, that means you are taking the correct right-handed rectangular coordinate system. In this fashion, if you see, I'm moving from x to y, let's suppose, right? In this fashion, you take yourself, you move from x to y, and then you see that this will like this actually. You have 4 fingers, right? And then your thumb is here actually. So this is how your hand is actually. Okay. Maybe my drawing is not that great, but that's how it is. So you have this 4 fingers and you have thumb. You rotate from X to Y in this fashion. And you see that your thumb is going in this direction. So this direction has to be Z, but my positive Z is this direction in this case. So this is not a right-handed rectangular coordinate system. So we won't take this for our studies. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.